So here's part C of number 6 from the 2012 AP Calc AB exam. And in part C, they want us to find the acceleration of the particle at time t, and then decide if the speed of the particle is increasing, decreasing, or neither at time t equals 4. And then, as always, quick explanation as to why we answer the way we do. And so we're given a velocity function to start with. The rate of change of velocity is acceleration. So the derivative of velocity is going to be our acceleration function. So to find our formula for a of t, all we're going to have to do is take the derivative of this. That's pretty easy to do as long as you remember to use the chain rule. The derivative of cosine, the outer function, is negative sine. And what we're going to put inside that negative sine function is the same exact inner function that we had back here, and that's pi by 6t. And then we need to multiply by the derivative of this inner function. Now pi by 6 is just a number, and the derivative of a number times t is just going to be that number. So here's our acceleration function. So that takes care of the first part of part C. Now the second part asks us to determine if the speed of the particle is increasing, decreasing, or neither at time t equals 4. Explain your reasoning. We actually need two things in order to answer this. What we need to know is we need to know what v of 4 is, and we also need to know what a of 4 is. So if we're looking to compute v of 4, the velocity of the object at time t equals 4, we're just going to put 4 in place of this t. So that's going to be cosine of pi by 6 times 4. I don't know why that was so hard for me there. So cosine of pi by 6 times 4, and then if you think about this as 4 pi over 6, that would be 2 pi over 3. So this is going to be cosine of 2 pi over 3. If you think about what that tells you about velocity using the unit circle, pi by 3 would be equivalent to a 60-degree angle. 2 pi by 3 would be 60 more degrees around the unit circle, so it'd put us about right here. Now cosine of that angle, we can find that. We can use our 30, 60, 90 ratios. We can use the left-hand trig routine to figure out what the actual value of this is. But all we really need to know to answer what we're asked here, it doesn't ask for v of 4. It asks us for the speed. We just need to know what the sign of velocity is, SIGN of velocity. And the sign of our velocity here is definitely going to be negative. The x-coordinate at this point on the unit circle is definitely negative, so our velocity is less than 0. What about our acceleration at 4? So the acceleration at 4, I'm going to clean this up a little bit as we evaluate it. I'm going to pull the pi by 6 out in front of the sine function. So I'm doing negative 1 times pi by 6 first, and then we need to evaluate the sine of pi by 6 times 4. Well, that's going to become 2 pi by 3 if we reduce it. It happened here too, right? Pi by 6 times 4 turned into 2 pi by 3. So I'm just going to toss down the 2 pi by 3. And so it's the same angle. Think about what the sine of that angle is. The sine of that angle is going to be the y-coordinate at that point. The y-coordinate is definitely positive. We're above the x-axis. So we have a negative coefficient times a positive value. That's going to give us a negative value in the end. We don't need to know the value, the exact value of velocity and acceleration at 4. We need to know which side of 0 it sits on. So what this tells us is that the velocity graph at the t value of 4, the velocity is going to be negative, right? We decided that a few minutes ago. So the graph is going to be below the x-axis, or the t-axis, I guess, in this case. And because our acceleration is also negative, and acceleration is the derivative of velocity, our velocity graph is going to be looking like this near the t value of 4. Reason why we know it's going to be going downward like this is because the derivative of velocity, acceleration, is negative there. And graphically, that corresponds to the slope of the tangent line. So we need to have a negative slope for our tangent line, a negative value for our velocity. What's happening with velocity along this little interval of the graph? Well, it's moving away from the t-axis. Velocity is becoming more and more and more and more negative. Since velocity is becoming more and more negative, the absolute value of velocity, which is equal to speed, is increasing. The explanation we kind of talked about graphically here. Since velocity is negative and acceleration is negative, velocity is moving away from 0, therefore the speed, the absolute value of velocity, is increasing.